Hello, my name is Samir Negi and welcome back to my channel. So today we are with count maximum gems, another power programmer question, and let's read the question first. So we are given a matrix like a city of gems which is 3 rows and n column. So number of rows will be always fixed. Each gem, like each cell has a particular value. We will always enter the city from 1 comma 1 and we will exit the city from 3 comma n. That means the last column of every row, and okay. So what we can do that we can actually move, we have some moves. So either we can move like down, we can move up, or we can move right. So there is no left move. Okay. And people are not city friendly, so if they see me visiting the same cell twice, they will put him in jail. So we cannot visit the same cell twice, and find the total number of gems will can get without visiting the same number twice. So basically we have to make a path from 1 comma 1 and 3 comma n to get the maximum number of score that we can get. Okay, so if you get any time at this problem, just make sure you have to use some searching algorithm like BFS or DFS, because you have to make that search. Now we will see the explanation in a whiteboard so that I can show you the example and what approach we are going to follow, so that if you are a programmer in Java or C++, you can write your own code. So I will see you there. So let's look what the question wants from us. But before that, if you haven't clicked on the subscribe button, please make sure you click on the subscribe button. Otherwise, you will be missing a lot of Infosys question that I post on my channel. So if you see, we have to start from here. So basically, this is our start node, and this is basically our end node. So if I see the best part where I can get the maximum number of thing, it should be like this. So if I start from 2, if I go here, then I get 4. If I go here, I get 6. I can go here, I get 8. I go here, I get 10. Then I go here, I get like 12. Then I got here, I get like 14. And I go here, like here I get 16. Then I can go here and 18. So in the end, I end up with 18, right? But to come to here, we have to follow a path, and that's what we are going to look how we should do it. Hi, to solve this, we have already seen what the best part to take, but BFS doesn't work on best part. So what does BFS work on? BFS work on two things. One is Q. So Q always go with BFS, and the other thing, it goes on every direction. So if this point is a current point, so it can go left, up, right, down, and left. But we know that left is not going to work for us, so we need to consider all these three different points. To work with the input matrix, we also have to create a max score matrix. So for the max score matrix, you can update it with any value, but I will say that update to a very negative count, because you know that in your question, the negative limit is minus 10 to the power 5. So update to a very negative count, but for now, I can just keep it as minus 1, 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 and the whole matrix is initialized by minus 1. So what I do is that I start with this. So the first matrix score becomes 2. So what I do, I write here 2. Then from here, either I can go down and I can go right. So what I will do, I will go here and go here. But at the same time, I'm going to update my values in the max score matrix as 4 comma 4. And then from, if I pick this one, then I can go down or I can go right basically. So that the same thing I'm going to do. So what I'm going to do, I'm going to update it to 4 plus 2 6, and similarly 6 will be updated here. Now if you pick this value, you can go here. There is no other direction you can go. You cannot go up because the parent is already 2. You cannot go down, which is out of bounds. So only place you can go is here. So what I do, I go here and I update the value as 8. Now you can pick, so it's a queue, so obviously these all values will be queue. Currently I'm picking up at random, but when in the question you will see that I'm popping out the value from queue. So we are going to do it in order. So now I can just pick this element from here, so it can update these value and it can update this value. So what will happen, so if I update this value, so it becomes 8 plus 2 10, because 6 is the less value, so it will be updated to 10. And similarly if I pick 2, this will become 8 plus 2 10 as well. So this has become 10. Now I'm here it can update the below one, the right one, and the up one. As below is a parent, we no need to update the below one, but it can go up and right here. So what I'm going to do, I'm going to update this thing. As 4 was value was less, so it become 10 plus 2 12, and this also become 10 plus 2 12. Now I'm here, right? So this has been updated, and now I'm here. It can only go right because it cannot go to the parent, because this is the parent it was last updated to. So it can go like 14. Then either you can pick this. So if you even pick this, so 12 can go towards up and down, but as you are in a queue, this won't happen, right? So as you're in a queue, this won't happen. So what you will do, you will pick this 12, and this is already 14, and basically this will go towards like 16 and then the 18, right? But if you say even you pick this two, like in the last moments, so let's say in the right, what I'm going to do, I'm not going to pick this two, I'm going to pick two. So when you're trying to update this, so it was 12 and this was 10. So this will not be updated because this value is higher than 12. So it becomes 12 plus 2 14. This value is already 14. So this will not become parent of this, but this value can be updated. So it will be updated to 12 plus 2 14. Right now you can pick this value, because uh, this is not the parent, so I can still update this value, and as this value is higher, so this value becomes 16, and then you go down again, and then become 6 value become 18. So this is what we have done. So this is the path we are going to follow, and now we are going to code it. So see you in the Visual Studio Code. So now I'm going to write a Python code for it. So this is my skeleton code where I have written all the test cases which I received in the Infosys Power Programmer question. Those were three. The first was returning 18, second was returning 1, and third was returning 20. So we have a function path here, and yes, so basically the driver code we will this. So first I'm going to initialize my all three matrices which I discussed, like parent, maximum score, and the max score. So what I'm trying to create a max score matrix, basically, which is from 999, parent which is from -1 and -1, and max score, the first element will always be equal to your actual array. And at the same time, I'm going to write a function for you guys, which if you want to run will be really helpful because it will print matrix in a great format. So this is what this function is going for you. So now if I try to print my max score matrix, you will see that it printed in a very beautiful way. So I just have to pass my max score matrix here. I go to my terminal, I create all this nonsense, I run this code, and you see it is printed like this. But in usual way, it will print it in a step-by-step format. I'm not sure why. So let me do plus maybe /n. So /n works, and then I save it, and then I go here, I run it again. Somehow it is not getting printed the way I want it. So maybe this /n, let's see. So clear it, run it again. No, it doesn't work. So that's this terminal has a problem that it doesn't recognize /n. But if you run it in a different terminal, it will print it in a line by like a proper matrix, and it will definitely work for you guys. Okay. So don't need to worry about it. It's just a print function. Now we have initialized all the matrix here. Now basically we need to see the valid directions that we can take. So basically to do that, we have to create one more function known as valid boundaries. And the valid boundaries are that the row should be always greater than 0 and less than the length of array. Similarly, we are not moving toward the right, so that's why j cannot be less than 0, but j should be less than the length of the array, because we are moving towards the right, we are not moving towards the left. Okay. Now we need to do is that we need to update every time we come to a position. We need to add something to the queue and basically go inside a while loop. So we do like this. So we create a queue, let the current position be 0. So I remove this is not necessary, and we go inside a queue. Inside a queue, we pop the current point, and we do a up. So what we are going to do, we are going to calculate the up. Similarly, we are going to do the down as well, and basically the down would be +1, and the right would be, so I write this way. So the right should be, this will not be here, and the y-axis will get +1. So this is the right point. This 3 point shows that we are moving up, down, and right. Now I'm going to write a function basically to update the matrix, and this is the most important function that we need to discuss. To write that function, what I'm going to use is that parent. So what my current parent is, if that's what we are calculating, right? In the parent matrix, we are storing that what we got updated from. Then the valid direction. So valid direction and the current parent is not the next one. So these are the two things that we are checking, that first we are moving in a valid direction, and that we are not updating the same cell what we have, like the cell we got updated from. So that what is the parent of us. Now, what is the old score? Old score will be the max score, and the new score will be the new score, which will be added from like the last max score with regards to the current point we are moving. So this will be the new score. If the new score is greater than the old score, then we add our point to the queue. We update our parent, we update the max score. These are the three things what we are going to do, and we are going to do it for every up, down, and right. So we do update matrix call for my up, for my down, and for my right. So I write it down here, and then I do a right. And this is everything that we are going to do. The last thing we are going to do is return our -1 -1. So what it's going to do, it is going to return the last column of the last column of the last row, and basically it will return the last cell. And we have done the update matrix 3 times, and we have explored every part of our matrix, and this should return give us our solution. Let me clear this for you and let me run this. It showed that every test case passed. That means this is a working solution. Apart from this, this is the most important function in the solution. So if you don't understand anything about this, please make sure that you write in the comment section and I will answer it for you. Apart from that, the question is pretty hard. I won't say it was very easy to solve, because I know BFS can be a little tricky. But thank you for the patience and thank you for watching this video. If you have watched the video till the end, please make sure to like the video as well, and I will see you soon in my next programming video.